Okay, so I'm going to talk a little bit about LeetCode, data structures, system design, basically the standard repertoire that you're expected to basically have a deep understanding of when you're being interviewed for a software engineering role, especially at like more high tier competitive companies, like your FANG companies or whatever. So on the one hand, it's been a while since I have studied this stuff. I studied it a bunch before my first interview 5 years ago. I think I did around 300 questions on LeetCode, and I didn't even really get asked anything for those positions because it was a different level of competition and just a different system. And I liked it. It was pretty low key. But I decided to take a stab at it again a while later, which I've done a little bit in between those things, but just not with the intensity that I'm picking up now. And on the one hand, I think data structures, algorithms, LeetCode style stuff, it's undeniably really challenging. If you're a person and you sit down to do it, it's going to probably be a humbling experience for 9 out of 10 people because I feel like it's a very challenging thing to do. You get better at it by learning and memorizing tricks that you apply over and over again. But it's such an abstract thing that requires so much specific knowledge that you would potentially never think of on your own. So it's very specific. Now that said, I think it definitely feels like a very different activity than programming. So I've worked on trying to make a video game for a while now. And when I'm programming to try and make a video game, I'm solving problems, but a lot of the time I'm not really utilizing these data structures or maybe even more some of the like tricky algorithm type things that they have. And I think part of it is because I'm probably not utilizing them because I don't know them well enough. But another reason is because the problems I'm solving just aren't they just don't fall into the same category as some of these very complex LeetCode problems that are like really pretty contrived a lot of the time. And that there's so many ways to get around it without doing any of that stuff. Probably one of the easiest things. A lot of the time, LeetCode is about taking some sort of data and like finding some calculation from it and doing it as quickly as possible so that you don't waste like time. But there's an even faster way of doing all of this in the real world, which is just pre-computing it and then just looking it up. So effectively, like almost all of the problems so many of them can be reduced down to, in like real pragmatic programming, to just literally pre-calculating it, putting it in a hash map, and then looking it up. Pretty much like how caches work, and you can cache for effectively anything. And so it's okay. So that's a little bit of a criticism where it's like data structures and algorithms and LeetCode style stuff. It's just arbitrarily complicated and the constraints aren't realistic at all. So it becomes contrived. But that's where its strength lies because it's so constrained, it really does challenge you. I would say LeetCode, probably out of a lot of the things that I can imagine, is one of the highest cognitive load things you can do. There's a lot of other things you can do as well, but it's definitely up there. And that's just good for you to probably do. Because if you're taking on high amount of cognitive load and you're able to sort through it, then you get a little bit better at doing that in the future. And there's no denying it does teach you to think in a certain way, such as being very cognizant of the space complexity that you're doing. Like you're trying to anticipate, preemptively predict what is going to be the speed and efficiency of this, and also what is going to be on the storage side of things. That is something I would say while I was programming for my game, I definitely did that a lot, where I'm like effectively thinking about what a single unit size is and then what that would be like multiplied times 100,000 users who then do it 100 times. And it's very basic math, really. But it's in the same vein as doing like some sort of big O notation is more vague than that because it's more of like a functional thing where it's, I'm not even going to tell you what it's going to concretely be. I'm just going to tell you what order of functional growth it's going to be in. I think that's very useful. I think it's a very good thing to do. And I do think that the best engineers would theoretically have all of this perfectly memorized and like instantly retrievable via like their intuition, right? And I think the system design stuff, this is getting more into the like, how do you build a distributed system that's an actual service that more than 10 people can use or something? That's like extremely pragmatic, but ironically, it starts to be totally different than data structures and algorithms. Like, you might end up using something like binary search in some small components of various different parts of the entire distributed system, but you don't really see that at so it's at a different level, and it's, I think, also super useful. But I think, okay, so I've talked about a couple of different things. Now I'm going to talk about AI. One, AI makes learning data structures and algorithms and system design like way easier because it effectively has indexed any of your questions and it gives you an answer that's probably like 99% correct because a lot of these problems have been dictated and conversed on the internet in a multitude of ways. And it can work with that. And it can basically utilize that to give you what you need very quickly so that you can basically put two and two together. That's pretty significant. But the other side of it is it can literally just solve a lot of the problems. And it makes you question why you're even learning this. And probably the main answer I would have for that is that it's just theoretically superior for you to have like a deep intuition about every part of a computational stack, no matter what. If you're going to be working with a programmed computer system, this intuition is effectively the only thing you really have and the most important thing. And even if there's this sidecar AI, which is increasingly more powerful at all of these different things, the minute the AI can't just completely solve the problem independently, it falls on to the next thing or intelligence to address the problem, and that is a human effectively. And that human is not going to be able to do that without intensive training, probably. Or one could maybe articulate that better by saying the more refined and like high speed and high throughput a person's like computer science intuition is, the better they're going to work with these systems and ultimately control, dictate, troubleshoot, whatever, right? But yeah, I would say AI is like incredibly frustrating in some ways because as a software engineer, you're sitting here and you're like suffering through all these problems, all of this inadequacy, all of this information overload. And then you're like competing with this highly refined statistical algorithm. Yeah, I don't know. And then you're getting these mixed signals from CEOs and the market in general. I think the market is the worst it's ever been for software engineers. And this is on a tangent, but ultimately it is super relevant to studying data structures, algorithms, and system design. Because it's relevant, like the reason people are doing this, number one, is so that they can survive, so that they can make money, so they can have a career. There's a bunch of people out here that do it because they enjoy it, and I think everybody to some extent probably enjoys it. But so if that goes out of the window and you really can't succeed with that anymore. Nobody's going to do this. And it's going to be like, oh man, you know how to do a binary search? It doesn't matter though. It's so there, I think it feels like there's diminishing returns for some of this knowledge because there's more people that have it, and there are alternatives like AI, which can maybe search it or interpret it or do some stuff with it like more efficiently than before. But probably the biggest thing is that there's just more people on the planet that are studying it, and I think the tech sector, the business tech sector, is stagnated a lot because it's like people just aren't coming up with that many good ideas anymore. And there's just too much saturation of the good ideas that already are dominant. So it's, I could be out here trying to make a cryptocurrency. I could be out here trying to make a search engine or a browser, and all those things would be like, it feels like they would be exercises in futility because it's like impossible to catch up with what already exists. And I don't know. So that, I think that is part of the reason things are the way they are now, because it's like you got to have a real profitability like strategy for if you're going to hire 10 people, which is like a tiny number. You're going to hire 10 people at $100K a pop or more. That's literally like $1 million of overhead every single year that you need to make back with your product. You're going to do that with a browser? You're going to do it with the search engine? And if all the entrepreneurs are thinking the same way that I'm thinking, they're like, yeah, I don't know how I'm going to do that. And so now there's just a bunch of programmers that effectively have these skills that are useful for theoretically creating and engineering stuff, but it's just too damn hard to actually make $1 million off of it and pay just 10 people to do it professionally. Now we'll see about that. On the flip side, you could say everything needs more data and we have more electricity and the internet is constantly expanding, and all of that's true. So I don't really know what the future is going to be. I think if the more things regress from the average or the mean, the more they're going to rebound just because of the statistical nature of that. So the fact that it might be in like a recess, which is pretty bad, probably means in some amount of time it's going to rebound and have another like run. And at that point it's good to be in tech because it's like you've got 5 or 6 years of easy jobs where there's tons of people hitting you up and there's maybe like pay raises and stuff like that. I don't really know. But anyways, that's my 2 cents on learning data structures and algorithms in 2025. I think it's a good idea, but I don't, about as good of an idea as a lot of other options people have. It's not like an amazing idea. Like it may have been 8 years ago, 10 years ago. So let me know what you think about it.